Let's look at some algorithms for modeling division with some bigger numbers. So the first example we want to look at is using the base 10 blocks. So I want to divide 726 divided by 6. So my first step is to take my dividend and represent it with the base 10 blocks. So on your screen you can see 726 in with the base 10 blocks. So I have 7 hundreds, 2 tens, and 6 ones. Now I want to divide it by 6. So what I'm going to do is I'm going to start by looking at the flats or the hundreds. And I want to group them into groups of size 6. So how many groups of 6 flats can I get? I have one group of 6 flats, and I'm left with one more flat plus my tens and ones. Okay? So I'm going to take that flat that's remaining and convert it into longs or tens. Now I'm going to look at the tens and I want to know how many groups of tens, of 6 tens, can I create. So I have 1, 2, 3, 4, 5, 6 up top and 6 on the bottom. So here I have 2 groups of 6 tens. And then we're going to do the same thing for the ones. I'm going to get one group of 6 ones. I've got that on the next slide here. Okay, so what happened? I had one group of hundreds, 2 groups of tens, and one group of ones. So my answer is that 726 divided by 6 is 121. Okay. All right, you should try on your own to divide 1008 divided by 8. So now, again, you want to represent your number 1008 with the base 10 blocks. That's your first step. And you're going to start in the biggest place value. In this case, since we have 1000, you're going to have a whole block, right? And at each step, you're going to ask yourself, how many groups of size 8 can I build? So try that on your own and let me know if you have questions. Let's look at the partial quotients algorithm. This is also sometimes called long sevens. So this is for your student who doesn't quite have their multiplication facts totally down, but they can use this to still get their division answer. Okay, so again, I want to look at 726 divided by 6. And so what you're going to do, it's called long 7 because we're going to do this long looking 7 thing. I'm going to ask myself, how many 6's can I subtract out of 726? So for kids, maybe 100 times 6 is not so bad, right? So they can multiply 100 times 6 to get 600, and we're going to subtract that off. So now I have 126. And now they're going to ask themselves, how many 6's can I subtract from 126? Well, maybe they're not really strong on their multiplication facts, so they don't see that I can multiply by 20, but they can multiply by 10. So let's just multiply 6 by 10 to subtract off 60. So they're going to take 10 6's out and subtract off 60, and they're left with 66. And then you could say, well, I could take away 10 more 6's, so I'm going to subtract 60 again, and I'm left with 6, and that leaves me with 1 6. So I'm going to take the number of 6's here that I've subtracted off, and I'm going to add those numbers up. Okay, so if I add those up, I get 121. So 726 divided by 6 is 121. Now, when your students get a little more confident in their multiplication facts, maybe they could jump straight to the 26's. But the idea with the long sevens is they don't quite have the multiplication facts down. So they just need to keep subtracting, in this case, subtracting multiples of 6 until they get down to 0. Okay, so if I ask you to use the partial quotients or the long sevens algorithm, I'm looking for you to show me how it's applied. So something like this. Don't show me even if you already know how to do it faster. Okay, so do it this way. All right, let's try it on our own. Let's use long sevens to find 4,224 divided by 32. All right, well, I can do 32 times 100. So maybe let's start with 100, and I'm going to write this as 100 times 32. That's going to give me 3,200. So let's subtract that. I have 4, 2, 0, 1. And so maybe now I don't really know what to do. Let's multiply by 10. So 10 times 32 is 320. So I get 407. So now I have 704. And maybe I get a little confident, so I say, let's try 20 times 32 this time. That's going to give me 640. So let's subtract that. I have 4. I'm going to have to borrow. So 64. And then maybe I can recognize that 2 times 32 is 64. So now I've gotten down to 0, and so I'm going to find my quotient by adding these numbers up. So I have 100 plus 10 plus 20 plus 2. That's going to give me 132. So 4,200, whoops, I can't talk right. 4,224 divided by 32 is 132. All right, once kids get comfortable with the long sevens, you can start moving them towards the standard algorithm. So the scaffold algorithm is called scaffolding because we've got this sort of scaffold thing going up here. So again, when you divide 6 into 726, the first thing you're going to do is look at the hundreds place. And you're going to ask, how many hundreds can I multiply 6 by to subtract from my dividend? So in this case, I can multiply 6 times 100. And these red zeros are reminding us that we're multiplying by hundreds, right? So 6 times 100. So then I'm going to subtract 600. And I'm left with 126, right? And now I'm going to ask, how many tens can I multiply 6 by? Well, I can multiply by 20, right? So 6 times 20 is 120, and I'm going to subtract. And again, this 0 is just reminding us that we're multiplying by 20, not just 2. Okay. And when I subtract, I'm left with 6, and the last thing I need to multiply by 6 is 1. So I'm going to multiply by 1 and subtract 1 times 6, which is 6. And so I'm going to add these up to find my quotient up here. Now, once kids are real confident with this, you can move into the standard algorithm where you see we no longer show those red zeros and we sort of collapse those numbers that were on top.